All right, welcome in, focused learners. Today, we are mapping out something absolutely massive. We are going to walk through a complete step-by-step explainer of the 2026 Data Science Roadmap. Seriously, by the end of this session, you are going to have crystal clear clarity on literally every skill and tool you need to go from the absolute basics all the way to advanced domain specialization. If you want to build a highly structured, super successful career as a data scientist, well, you're exactly where you need to be.
So, think about this for a second. You use AI every single day, right? But can you actually build it? It's a serious question. We are constantly interacting with tech fueled by big data. I mean, whether we're endlessly scrolling on our phones, shopping online, or binge-watching movies. But today we're actually going to learn how to build the systems behind the magic.
Okay, let's dive straight into this. Here's our blueprint. We're going to cover 6 crucial steps, starting with the data science revolution, moving right into Python and pre-processing, tackling math and visualization, mastering the machine learning core, advancing up to deep learning and AI, and finally, we'll wrap things up with some absolutely essential career success tips.
Let's kick things off. Section 1, the data science revolution.
Look, data science is essentially this ultimate merger of math, programming, and machine learning, and it is literally powering the modern world. Just think about your daily interactions. You've got Netflix recommending your next show, Amazon suggesting products, self-driving cars, drone deliveries, and of course, modern large language models like GPT, Gemini, and Claude. Tech, fintech, and healthcare companies are all desperately looking for professionals to make sense of the billions of users generating this data. They need us to step in and build actual, useful products out of all that raw information.
Moving right along to step 2, Python and pre-processing. This is where we handle the messy data. So how do we actually become one of those highly sought-after professionals? Well, when you're starting out, you're basically faced with a choice, Python or R. Now, while R is fantastic for some really specific statistical modeling, I am strongly going to recommend you start with Python. It's incredibly popular, remarkably easy to learn, and there is massive industry demand for it. Honestly, if you're looking to secure an AI engineering role, Python is the absolute gold standard in the industry.
Now, once you've got the basics of Python down, things like variables, loops, functions, you really need to master these essential pre-processing libraries, NumPy and Pandas. Why? Because, spoiler alert, real-world data is incredibly messy. It's full of missing values and weird errors. NumPy is built specifically for numerical computations, right? And Pandas sits directly on top of it, basically acting as your ultimate tool for data manipulation and cleaning. You absolutely have to pre-process your data using these tools before you even think about applying any fancy algorithms.
All right, step 3, math and visualization. This is how we start seeing the patterns.
Now, I know a lot of people find this part a little terrifying, but let me reassure you right now, you really only need 10th grade math to start. Seriously, don't sit there trying to memorize a bunch of definitions, just focus on understanding the intuition. You do not need some advanced PhD. Data science is a practical field, so you just need a practical, working understanding of the behind-the-scenes logic. That way, you can confidently explain what your algorithms are doing during your job interviews.
So here is exactly how you build that mathematical foundation. There are 4 main pillars to focus on. 1. Statistics, so understanding mean, median, variance, and standard deviation. 2. Probability, focusing on conditional probability, distributions like normal or binomial, and Naive-Bayes theorem. 3. Linear algebra, basically getting a solid grasp on vectors and matrices. And 4. Calculus, specifically differential calculus and derivatives, like dy dx, just so you understand how graphs and charts actually change. Oh, and if you want a fantastic resource for this, the book Essential Math for Data Science is a real game changer.
Okay, so once you have the math down, you actually need to communicate your insights to your non-technical teammates, like, your managers. For data scientists, Python libraries are key here. Matplotlib gives you that granular, low-level control of your plots, while Seaborn is just amazing for whipping up quick charts with minimal code. But, quick side note, if you're also targeting data analyst roles, you'll definitely need to master dashboard tools like Power BI or Tableau.
Moving into the fun stuff. Step 4, machine learning core. Time to make some predictions.
Before we build anything, we really need to separate the buzzwords from reality. Artificial intelligence is the broad, overarching concept of training machines to perform human intelligence tasks, like converting speech to text, for example. Machine learning, on the other hand, is a specific subset of AI. It's the actual, tangible algorithms that use raw data to make predictions or classifications.
And machine learning basically breaks down into 2 main paths.
On the one side, we have supervised learning, which uses labeled data. The output is clearly defined, kind of like training a model on known health records so it can predict if a brand new patient is healthy. Then, on the other side, we have unsupervised learning, which uses unlabeled data. Here, the system has to go in and find hidden patterns all by itself, creating clusters or groups out of the raw data without any clear outputs given to it. There's also a third type, reinforcement learning, which uses rewards and penalties, kind of like training a puppy, but honestly, that's mostly used a bit later on in deep learning.
So to actually build these supervised and unsupervised models, you've got to have the right tools. Enter scikit-learn. This is the primary Python library required for building machine learning models. It's not a nice-to-have, it's an absolute must-learn. For some really deep hands-on practice, I highly suggest grabbing a copy of the book, Hands-on Machine Learning with Scikit-learn. It's fantastic. But hey, remember, your machine learning models don't just exist in a vacuum. You need developer tools to interact with the real world. You've gotten to know SQL to fetch and extract data from relational databases, which are heavily used in large organizations. And you absolutely must know Git and GitHub for version control. That way you can safely collaborate with other data scientists on the huge amounts of code you're going to be writing.
Next up, Step 5, Deep Learning and AI. This is basically the 2026 necessity.
You know, a few years ago, this tier was totally optional. Today, it's a necessity. High competition means you have to know this. Deep learning relies on artificial neural networks to basically mimic the human brain, and there are three core architectures you've got to get familiar with. First, feed-forward neural networks. That's your absolute foundation. Second, convolutional neural networks, or CNNs, which are specifically designed to extract information from images and video. And third, recurrent neural networks, or RNNs, which are used for processing text and natural language. Oh, and when you're learning these, my personal recommendation, go with the PyTorch tool over TensorFlow for building your models.
And this brilliantly illustrates where all of that leads. Once you master those networks, you can specialize in major AI domains. You've got generative AI, creating net new text, video, or audio content. Think modern LLMs. You've got natural language processing, or NLP, focusing on human language through chatbots and translation. And you've got computer vision, which processes visual data for things like self-driving cars and drones. Now, don't panic. You don't need to learn them all deeply at once. Just understand the basics before you build a specialized career over the years.
All right, we've made it to Step 6, Career Success Tips. Let's talk practical survival. Look, I really cannot emphasize this enough. Data science is not a theoretical field. It is a highly practical field. Just memorizing concepts, that's not going to get you hired. You need tangible, undeniable proof of work on your resume. Simply put, you have to get your hands dirty.
So what are the actual key actions for success here? First off, build projects using real data sets from platforms like Kaggle. Second, don't just build them on your local machine, deploy them. Use tools like Streamlit or Hugging Face so recruiters and others can actually interact with what you build. Third, and this is a huge one for long-term success, target specific domains. If you do an internship in finance, try to get your first job in finance and then maybe apply to a fintech company later. That deep, specialized domain expertise makes you immensely valuable. And finally, if you're a fresher right out of school, make sure you learn basic data structures and algorithms, specifically time and space complexity, so you can easily pass those entry-level tech interviews.
Okay, so what does this all look like in reality? Well, if you dedicate about 3 to 4 hours to studying daily, this entire roadmap requires a solid 4 to 6 months of consistent, hard work. Month 1 is all about Python and math. Months 2 and 3, that's Core ML and SQL. Months 4 and 5 are for diving into deep learning. And month 6 is dedicated entirely to building your projects and getting them deployed.
So, there you have it. We've mapped out the entire journey. This blueprint takes 6 months of deep, unwavering focus, especially if you're in your early 20s. The time to put in the hard work and really prioritize your career is right now. You've got the resources, you've got the roadmap right in front of you. So my final question to you is this: which domain are you going to conquer first? Pick an industry, start the hard work today, and go transform it. Thanks so much for joining me on this explainer today. Keep exploring, and I'll see you next time.